Hi, everybody. This time we're going to talk about temperature scales and how to convert between Celsius, Fahrenheit, and Kelvin. Now, in the United States, we commonly use the Fahrenheit temperature scale, and it was developed back in the early 1700s by Daniel Fahrenheit in Germany. Now, this is a very familiar scale, but there's a problem with it in science. The numbers that are used for the freezing and boiling points of water are arbitrary. And because of this weird situation, it made it very difficult for scientists to reproduce this scale back in the early 1700s and the early 1800s. How does one scientist hundreds of miles away communicate scientific data to another scientist? So they came up with some better scales. And these are the ones that are commonly used in science. And that's why we need to study them as part of our class. First, it's the Celsius scale. Now, the Celsius scale was invented by Anders Celsius. It is based on water, and the metric system, as you may recall, is based on the number 10 and the most common compound that we have, water. 0 degrees Celsius is the point at which water freezes, and 100 degrees Celsius is the boiling temperature of water. So this was easy to reproduce. When one scientist was trying to write letters back in the 1700s to another scientist and say, this chemical reaction happened at this temperature or that temperature, it was very easy to communicate and create a temperature scale by boiling and freezing water. So that was pretty easy to do. After the Celsius temperature scale was invented, Lord Kelvin, who was a British gentleman, came up with an idea, and the idea was the concept of absolute zero. Well, heat is the result of molecules moving, and if molecules are moving slowly, that is an indication of cold. When things get hot, things move faster. Molecules and atoms move faster. Well, Kelvin asked an interesting question. His question was, if slow moving objects mean cold, can you get to a point where there is zero motion? And if there's no motion and no vibration, is there an absolute cold? Is there a temperature at which nothing moves? That number was found, and that number we referred to as absolute zero. A temperature scale that uses the same size degree as the Celsius temperature degree was developed, and 0 Kelvin is absolute zero, the coldest possible temperature that is known. And because heat is a result of motion, and if you have no motion, you have no vibration, and that is as cold as you can get. This is a lovely little chart, and it is going to compare the Kelvin, Celsius, and Fahrenheit scales. So let's take a look at these. At absolute zero, Kelvin is 0 Kelvin. Celsius, it's minus 273 degrees Celsius and minus 459 degrees Fahrenheit. That is, as you can imagine, very, very cold. Matter of fact, it is as cold as you can possibly get. Now, the Celsius and the Kelvin degree have the same size degree. 1 degree is the same for Celsius and Kelvin. Now, 0 degrees Celsius is the temperature at which water freezes. The Kelvin temperature scale, that is equal to 273 Kelvin. Now, you may notice a slight differentiation of how these temperature degree indicators are written. You'll notice that for Kelvin, it is just indicated with a capital K. When you're talking about degrees Celsius, there is a little 0 as a superscript next to capital C for Celsius. And degrees Fahrenheit, it is a small 0 next to capital F for Fahrenheit. That is convention. That's how it is done. And I just want to point that out because sometimes people say, why didn't you put a little zero next to the Kelvin? That is just not convention and not how it is done. So I wanted to let you know that. So water freezes at 273 Kelvin, 0 Celsius, and you may be familiar, 32 degrees Fahrenheit. Now, body temperature, most of us know that's 98.6 degrees Fahrenheit, and those of you in the health profession may be aware that that body temperature number, different studies have shown that that number has fluctuated slightly through time, so that number might be a little bit different than what you're learning in a nursing class or something like that. Go with what they're teaching you there because they have the most up-to-date data. What temperature does water boil at? Well, water boils in the Fahrenheit scale at 212 degrees Fahrenheit. Celsius is 100 degrees Celsius. And Kelvin, because it's the same size degree as Celsius, it's going to be 100 degrees more than the temperature at which water freezes, so 373 Kelvin. Now, we're going to spend some time in the rest of this talk talking about how do you mathematically calculate between Fahrenheit and Celsius, Kelvin and Celsius, and vice versa. This page is important. Make sure you put a highlight by it and copy down these equations. So we're going to practice this collection of calculations, and on tests and quizzes, you are going to be expected to be able to do this. So let's practice now. So I have copied our equations up here. So let's go about doing this. Room temperature. Let's say room temperature is 68 degrees Fahrenheit. What temperature is that in Celsius? First thing you do is pick out the right equation. We are trying to find Celsius and we know Fahrenheit. So which equation do we use? We use the one that says find Celsius from Fahrenheit. So this is the equation we want. So degrees Celsius is going to be the degrees Fahrenheit, which is 68 minus 32, and I'm getting this from this equation up here, 68 minus 32, and that's in parentheses divided by 1.8. If you remember your rules for math, always do the things in parentheses first before you do the division. So 68 minus 32 is going to be 36 divided by 1.8, and order of operations is important. When you grab your calculator, 36 divided by 1.8, we're going to end up with an answer of 20 degrees Celsius. It is very important in science you always label with a unit whatever you are dealing with. Okay, the second part of this is what is that in Kelvin? So we go to the other side, find Kelvin from Celsius. And none of these show us how to go to Kelvin from Fahrenheit, so we're only going to find Kelvin from Celsius degrees. And it says right here, Kelvin is going to be equal to degrees Celsius plus 273. So 20 degrees Celsius plus 273. If you need a calculator, take it. If not, you can do this when you're in your head. 273 plus 20 is 293, and that's Kelvin, so we label it with a capital K. So how'd that go? Not too bad? All right, let's try another one. And remember, in videos, you can always hit pause and slow me down and watch again if things go too fast. All right, let's try another one. Oxygen freezes at 54 Kelvin. What temperature is that in Celsius? So we're going from Kelvin to Celsius. Which equation do we use? So from Kelvin to Celsius, that must be this one. We want to know Celsius. Oh no, see, that's why you got to take a moment and make sure you're doing this right. I want to find Celsius from Kelvin. So degrees Celsius equals Kelvin minus 273. So that's going to be 54 minus 273. And the answer is going to be minus 219. Whoops, wrote it wrong. Minus 219 degrees Celsius. Always label what you've got. Now that is below the temperature at which water freezes. That's why it's a negative. The second part of this is what temperature is that in Fahrenheit? Well, we're going to find Fahrenheit from Celsius, so this is the equation we want. Degrees Fahrenheit is 1.8 times degrees Celsius plus 32. So this is going to be 1.8 times a negative 219 plus 32. So we always do the multiplication first, then we do the addition. So 1.8 times 219, even though that is not a negative sign, this is a multiply. This up here is a multiply. That's not a subtraction. That just has a negative number in here. So 1.8 times a negative 219, this is a negative 394 plus a positive 32. That comes from there. So my degrees Fahrenheit is going to be a negative 362 degrees Fahrenheit. And that is that conversion. So here's what I'm going to ask you to do. Try this one, hit pause, do this all by yourself, and then I'm going to go through at warp speed, and we'll see if you got it right. Okay, what is this in Fahrenheit? I know Celsius, so Fahrenheit is going to be 1.8 times degrees Celsius plus 32. So 1.8 times 998 plus 32. This is gonna be, boom, ba-doop, ba-doop, ba-doo. I got 1828 degrees Fahrenheit. And then the second half, what is this in Kelvin? Well, Kelvin, I can't go from Fahrenheit to Kelvin. I've got to go back to the original Celsius to go to Kelvin. So find Kelvin from Celsius. Kelvin is going to be equal to Celsius plus 273. So this is going to be 998 plus 273. And I ended up with 1030 Kelvin. One last word before we end the video. When you did your calculations, you may have gotten on some of the calculations a little extra digits past, like 1828 point something coming out here. We will talk in other videos about significant figures. How many digits do you include? But that's a certain amount of rounding off occurred, and that is why you did not necessarily, I did not write all of those down. All right, there are going to be some homework problems like this on your study guide. Practice them. Make sure you know how to do these because you're going to have a couple of these on your upcoming quiz or test. See you later. Bye-bye.